Today we're going to talk about the area of regular polygons. Remember, regular polygons have all sides and all angles congruent. If you don't have your calculator out, pause the video, grab your calculator because you're going to need it today. First, we have to define some terms. So I have an example of a regular polygon there, inscribed in a circle because that's going to help us define some of our terms. So the center of our circle would be the center of that inscribed would be the center of the circle the polygon is inscribed in. You could also think about it, it's the intersection of all of the diagonals, so that's going to be O. Now the radius is from the center out to one of the vertices, or that would be the radius of the inscribed circle. So an example of that would be segment OD, segment OE. From the center out to one of the vertices. Now the central angle would be angle FOE. So that's from the center, and that's the angle that makes up one of the sides. And how you find the central angle is you take 360 and you divide by the number of sides, because you're going to split 360 degrees, the degrees in a circle, by the amount of congruent sides. Now the apothem is from the center perpendicular to the sides, so that would be OX. The apothem is from the center perpendicular to one of the sides of our regular polygon. Now let's talk about how to find the area. As I have been doing all along in all of these sections, I've been deriving the formula for area. So let's think about this. What we have for area is in our regular polygon, we're going to have a certain amount of congruent triangles. This triangle, triangle FOE, is congruent to triangle EOD. So we're going to look at the area of that triangle. Well, the area of that triangle is 1/2 the base, so the side of, for example, FE. So that's the side length of one of our sides of our equilateral, so of our regular polygon. So side of regular polygon times the height, well, that's the apothem. And we're going to take that and we're going to multiply by the number of sides. So I'm going to multiply that, I'm going to put it below, by the number of sides of our regular polygon. In this case, it's a hexagon. We're going to have a bunch of different side lengths, a bunch of different number of sides. So area of our regular polygon. So 1/2 the apothem. Typically, we just write that as A. So that stands, A is going to stand for apothem. So if you're not really paying attention and you're just writing stuff down and you're not paying attention to what I'm saying, you're not going to know what A means. A stands for the length of the apothem. Now, the side length, this really stands for side length. Side length times the number of sides, that's perimeter. So area is 1/2 the apothem times the perimeter. 1/2 apothem times perimeter. Okay, find the perimeter and area of a regular hexagon with a apothem of 6. Okay, so I always like to draw in what we're given. So that's 6. To find the central angle, that's 360 divided by the number of sides I have, which is 6. Well, that's going to be 60 degrees. So if I were to draw it in, this whole angle is 60. So if I'm just looking at this small triangle here, because I have an equilateral triangle, because all of the radii of our regular polygon are congruent, that angle there is 30. So I have a 30, 60, 90 triangle. And we're going to be doing a lot of these, so make sure you understand this one. Okay, so I know the apothem. So I need to find the perimeter, so I need to find the side length. Well, okay, so I know to find the side length, that is going to, I'm going to call this x. The whole side length is going to be twice x. So if I'm solving for x, okay, so I have 6 over something is going to be x over something. With the side opposite the 60-degree angle and a 30, 60, 90 triangle is root 3. So 60-degree side over 60-degree side, 30-degree side over 30-degree side, so that's going to be a 1. So x is equal to 6 over root 3, multiplied by root 3 over root 3. 6 root 3 over 3, or 2 root 3. So half the side length, since this is an equilateral, or I'm sorry, it is an equilateral triangle. It's also isosceles, but since it's equilateral, half the side length is 2 root 3. So twice, or the entire side length, is 4 root 3. So perimeter is going to be the number of sides, 6, times the side length, which is 4 root 3. So that's going to be 24 root 3. Area is 1/2 the apothem times the perimeter. 1/2, our apothem is 6, times our perimeter, which is 24 root 3. Okay, so therefore, our entire area is, going to be 72 root 3. I didn't give us units. And notice how that guy's in simplest radical form. Look at all that work I had to do for that one. All right, our next example. Find the area of a regular octagon with side length of 5 and apothem 3. Okay, that's not as bad as the one we just did. So area is 1/2 the apothem times the perimeter. 1/2. Will they give us the apothem? The perimeter, well, that's going to be 8 times my side length of 5. So therefore, our total area is going to be 60. Again, I didn't give us units. You don't have to put units squared. The next one, find the area of a regular hexagon with side length of 12. All right, so this length is 12. If you memorize that a hexagon, when I drop down that apothem, you get one of these is a 30, 60, 90 triangle. Because this is congruent to that. This length is 6. This is 30. So our apothem is opposite the 60-degree side, which is 6 root 3. So the area is 1/2 the apothem times the perimeter. Well, the perimeter, each side length is 12. I have 6 of them. So that area, in simplest radical form again, is 216 root 3. So that one wasn't as hard as the first one. Looks like the first one was the hardest one so far. Next example. Find the area of a regular pentagon inscribed in a circle of radius 8. So when we're talking about the radius, that's giving us that side. Okay, I don't have it drawn in there. But that is what this circle would look like. Okay, so I have a circle has radius 8. That means the radius of our, from the center to a vertex, the radius of our regular polygon is also 8. Whew, okay, I know this one's going to be a lot of work. So let's talk about what the central angle is. The central angle, or this angle here, is 360 divided by the number of sides, which is 5. That means that that whole entire central angle is 72. A lot of times we're just going to be dealing, 99% of the time, we're going to be dealing with half of that because we're going to be looking at that triangle. So this is 36. That's the angle that we need. I need to find both the apothem, let's call that A, and half of the side length because the triangle that we draw in is isosceles, so those two sides are equal. When I drop down the perpendicular, the base is cut into two congruent segments. I need to find that length, S. Okay, since 36 is not one of our common angles, we need to use some trigonometry. To get A, if I know the hypotenuse, and I know, and I'm looking for A, the adjacent side, I'm going to use cosine. Cosine of 36 is the adjacent over the hypotenuse. So A is going to be 8 times the cosine of 36. Now let's just keep that in mind. I'm going to do that down here. I'm going to plug in down here. Area is 1/2 the apothem. So that's 8 times the cosine of 36. Notice how I'm not typing anything in my calculator yet. And this is what I want you guys to do. So 1/2 the apothem times the perimeter. Okay, so let's talk about how to get perimeter that we're going to plug into this formula and then plug into our calculator. Okay, so the perimeter, since I have 5 sides, it's going to be 5 times something. This side length is half of the whole side length. So if I find S, all I have to do is multiply by 2. I need to find S in that right triangle. That's the opposite, and I've given the hypotenuse, so let's use sine of 36 is equal to S over 8. So S, half the side length, is 8 times the sine of 36. So twice S, or the entire side length, is going to be 16 times the sine of 36. Since there's 5 sides, I have to multiply by 5, so it's 5 times 16 times the sine of 36. Now that's just a matter of typing in your calculator. Make sure that when you type this in, first of all, you're in degree mode. When you type in your calculator, for most of you guys, you need to remember to close out cosine 36, then close out the parenthesis. So you might have a double parenthesis in there. Sine of 36, close out that parenthesis, or else you're going to get the wrong answer. When I typed this in my calculator, I got 152.17 square units. Again, I didn't give us units, so we don't have to worry about putting any units down. There are your 2 lesson questions for the day. Please make sure those are submitted on time.